All right, guys, today we're going to talk about adding and subtracting like fractions. Now, like fractions are fractions with the same denominator, and there's something pretty nice about fractions with the same denominator, because what happens is when you're adding, all right, and the denominator is the same, so in this case we've got the common denominator of c, the denominator stays the same, and you just add the numerators. And as long as c does not equal 0, because you can't have 0 in the denominator, it will be undefined. Same thing is true with subtraction. We've got both denominators are c, so that denominator stays the same, and you would just subtract the numerators. So that makes our life a little easier. So for example, if you want to find the sum or difference and write in simplest form, if you notice we have 2/5 plus 4/5. Okay, we know our denominator's going to stay the same. It's going to stay fifths. All right, and all we have to do is add the numerators, or do 2 plus 4, which gives us 6. That tells us our numerator is 6. And then this is an improper fraction, so we should change it to a mixed number. So 5 would go into 6 once, with 1/5 left over, and there's our final answer. Okay, with subtracting, here we know we have a common denominator of 4, okay, or a like denominator of 4. Okay, so we need to, this is subtraction problem, so we need to subtract our numerators, or do 3 minus 1, which is 2. So we would have 2/4, which we simplify down to 1/2. All right, so let me move this up so you guys can see it. Let's first of all, so we get that out of our way. Okay, let's move this up. Let's go to problem number 3. Okay, we have 4/9 minus 7/9. Now, our denominator is going to stay the same. It's going to stay 9ths. But we got to think of this. We're going to go 4 minus 7. So you guys got to apply your integer rules that you learned before. All right, that's going to be 4 minus 7. It's like 4 plus a negative 7, oops, which is -3. So we're going to have a -3/9, which we would simplify down to a -1/3. Okay, because we have a smaller fraction minus a larger fraction. In number 4, we have m equals 2/5 plus 2/5 plus 2/5 plus 2/5. So we know our denominator here is going to stay 5. But basically what we're doing is we're adding 2 to itself 4 times, right, which equals 8. So we're going to have 8/5, all right, which 5, that's improper, so we're going to change it to mixed. 5 will go into 8 once, with 3 left over, and we keep that same denominator. So we have 1 3/5. Now, here, we have -3 3/8 minus a -5/8. Now, the only reason the parentheses are there is to make sure you realize that's a -5/8. So we are going to keep that 8s for a denominator, but see where this is, you see where I've been pulling the numerators off to the side and writing the problem? When integers are involved, okay, it's kind of easier to see, like this is basically, we're going to have -3 minus a -5. That's our subtraction problem from the numerators, which is the same as -3. Remember, we've got to follow our integer rules. We're going to change subtraction to addition, sign on the second number to positive. So it's like we have -3 plus 5, which gives us 2. So really what we have is a 2 in the numerator, which we simplify down to 1/4. Okay, so it often helps to take that problem that's from the numerators and really pull it off to the side, especially when negatives are involved. Okay, so like for example in this one, we have to subtract -3 and 5/6 from 4 and 5/6. So really, so we're subtracting -3 and 5/6 from the 4 and 5/6. We actually have to write that 4 and 5/6 first, and we're subtracting a -3 and 5/6. Now, something that sometimes helps people with mixed numbers as far as what they should do is just pull out the number, the whole number part to get an estimate. Like I would take 4. You could almost look at it as 4 minus a -3. Now, if you're doing that problem and just looking at the whole number part, it'd be like plus a +3 or 7. Now, 5/6 is almost one whole. 3 in both cases here, so you could almost even look at it as it's kind of like if we round it up, it almost be like 5 minus a -4, which is plus a positive, so we're looking at kind of like 9. So the answer is going to fall somewhere between 7 and 9. So if we look at this would be plus a positive, and we'd be looking at 7 and 10/6. And sometimes people like to write this vertically so they can see it better. You might be more used to this. Okay, so it might be a little easier to see 7 and 10/6. Now, we can't leave the answer like this. Our fractional part is improper. So we got to kind of think of this as 10/6 would be 1 and 4/6, or 1 and 2/3. So we can take that whole number 1 and that whole number 7 that was already there, and we have 8 and 2/3 for a final answer. All right. So let's switch to the back of the paper, please. All right, guys, let's look at example number 7. It says you bought 2 storage blocks for your bedroom. One is 4 3/4 inches high. The other is 9 3/4 inches high. You want to stack them under your window, which is 24 inches from the floor. Okay. Will they fit? All right. So what we want to do is we want to find out what those 2 storage blocks total will be, and then we can know whether or not it will fit. So I want to do take 14 3/4 inches and add 9 3/4 inches to it. Okay, so we need to add our fractional parts. So 3/4 plus 3/4 will give us 6/4. Remember, the denominator stays the same. And then 14 plus 9 is 23. But we're not quite done yet because 6/4 is improper. 4 would go into 6 once, with 2/4 left over, where it would add 1 whole to that 23 to make it 24, and 2/4 would be a half, so that's 24.5 inches. So when I'm asking the question, will they fit? You'd have to say no. The storage blocks will not fit. Okay, so kind of answer it. They're actually, you'd almost even add on and get more specific. They are a 1/2 inch too high. Okay. Now, we also obviously need to apply our algebra. Okay, and I would again highly recommend plugging in all your numbers first and then dealing with the problem. It says evaluate each expression, and it says a minus the sum of a plus b. We got parentheses there, so we're going to have to follow order of operations here. But let's plug in our numbers first. This would give us a is -2 1/8 minus, and in parentheses we're going to have -2 1/8 plus -1 3/8. Okay, now we got to follow our order of operations. So we need to do our problem inside the parentheses first. So this first -2 1/8 is going to stay the same. I'm not touching that subtraction just yet. And then we have -2 1/8 plus -1 3/8 is going to be -3 4/8. Now I could simplify 4/8, but I can see that I already have 8s over in my other number. So I'm going to leave it 4/8 for now to keep that like denominator. Okay, so now, and again, if you want to kind of check yourself of how you did inside the parentheses, you could look at it as do a little estimate. It would be like -2 plus a -1 if you just looked at the whole number part, which would be a -3. So that makes sense, that -3 4/8. Now, if we look at this one, now we have the rest of our problem to do. We could look at the whole number part again and say, well, that's -2 minus a -3. We'd have to change to plus a +3. So we're looking at somewhere around a +1. So we'd have to change this to plus a positive. Now, what do we get? How we got that actual +1 was we actually did 3 minus 2. Our larger absolute value minus our smaller. So I want to look at this as 3 minus 2 is 1, and then 4/8 minus 1/8 would be 3/8, and it should be positive. So there's my final answer, and that is simplified. Okay. Let me move this up so we can go to another example. Okay, here, number 9, it says find 5/2b plus 3/2b and write in simplest form. Well, again, the same concept applies. That 2b in our denominator is going to stay the same. And we just need to add our numerators. 5 plus 3 gives us 8. Now, the one thing we need to do, though, is we need to simplify. And you got to think of it as, is there anything we can divide both numerator and denominator by? Well, we can divide numerator and denominator here by 2. Because 8 divided by 2 would be 4. And 2b divided by 2 would just leave you a plain old b in the denominator. So 4 over b would be your answer. All right. And here, in number 10, we have 11 and 1/7 minus 5 and 5/7. Now, here, I like to set up any subtraction of mixed numbers vertically. Because what's going to happen is a lot of times you're going to actually have to do what we call rename or borrow. Because like here, we have 11 and 1/7 minus 5 and 5/7. Now automatically what some people do is they go, oh, 5 minus 1 is 4. But really this is 1 minus 7, so we don't have quite enough to subtract there. So we're going to have to rename that 11 or borrow from that 11. We're going to take that 11 and make it a 10. And then we're going to borrow 1 whole from it. But when we borrow 1 whole, we're going to borrow it as 7 over 7, because that 7 over 7 is the same as 1, but we want to keep that like denominator. We already had 1/7 there, plus the 7/7 we renamed or borrowed gives us 8/7. Now we can subtract 8/7 minus 5/7 gives us 3/7. And then 10 minus 5 gives us 5. So we get 5 and 3/7. So I really like to set up subtracting of mixed numbers vertically in case I have to do this borrowing. It makes it easier for me to see that. Okay, so now what I want you guys to do is I want you guys to pause the notes, try these practice problems, and then we'll go over them when you start the notes back up again. Okay, pause in 3, 2, 1. All right, guys, let's go over these practice problems real quick. Okay, number 1, 3/4 plus 3/4. We're going to keep that denominator of 4. 3 plus 3 gives us 6. Now, 6/4 is improper, so 4 would go into 6 once with 2 left over. So it'll be 1 2/4, which simplifies down to 1 1/2. Okay. In number 2, we have 5/9 plus a negative 7/9. So we know we're going to keep that denominator of 9. And we got integers involved, so I'm going to just look at the numerator part of the problem. We have 5 plus a negative 7. So 5 plus a negative 7 is actually a negative 2. So we're going to have negative 2/9 for our answer, and that is simplified. Okay. In number 3, okay, we have 3 4/9 plus 8 2/9. So 3 plus 8 would be 11. And then 4/9 plus 2/9 gives me 6/9. Now that can be simplified. 6 and 9 can both be divided by 3, so we're going to have 11 2/3. Okay. In number 4, we have 11/12 minus 5/12. So our denominator is going to stay the same, and 11 minus 5 is 6. So 6/12, when we simplify that, is 1/2. Okay, let me move this up. Okay, it says evaluate Q minus R if R is 7 3/5 and Q is 9 1/5. Now, we would have 9 1/5 minus 7 3/5. So I see that I have mixed numbers being subtracted, so I'm going to set this up vertically. 9 1/5 minus 7 3/5. Now I can't do 1 minus 3 here, so I'm going to have to do that renaming or borrowing. This 9 is going to become an 8. And I got 1/5 already there, but I'm adding 1 whole to it as 5/5 to get 6/5. So now I can do, oops, not 6/5, hello. So we have 6/5 minus 3/5, which gives me 3/5. And then 8 minus 7 is 1, so we get an answer of 1 3/5. Then here, we're going to keep that denominator of 8. And what we have here, y plus 5y. Remember that we assume it's basically like 1y plus 5y, which will give us 6y. And then we can divide both the 6 and the 8 by 2. And we would get 3y over 4. Okay, so hopefully that gives you guys an idea of how to add like fractions. We'll work some more with this tomorrow in class.